Hello, everyone. So we gather here again to discuss the opportunities in bioengineering field, and today we will be focusing on biomedical engineering. So for this session, there are two of my good friends again joining me. The first one is Dr. Ronald Pradhan, who is technical product manager at Health RX, which is a section of Bajaj Finserv Health Limited. And the second panelist today is Dr. Anish Sathe, who is the CEO and co-founder of Curative, the company which
Hello.
works on AI-based diagnosis of cancer. So yeah, today we would be discussing from the perspective of how biomedical engineering field uh, has been working on and what the future looks like. So I would begin my first question with you, Ronak, actually, because you have taken biomedical engineering as an undergraduate course. So since most of these students are undergraduate students or prospective undergraduate students, they would be very interested to know how do you find? I mean, so you would have looked at the technology course while you were taking the biomedical engineering course. So how did you find these two courses different?
Okay, so just to present an overview, so biomedical engineering is like this broad overview. So it's an umbrella under which the different aspects of uh, how biology is involved with medicine and what are the different applications on how essentially medicine can play a role or biology and can play a role in improving someone's life is what essentially falls under the biomedical domain. So under that, if I were to define what biomedical engineering especially means, so it essentially talks about how engineering techniques can be applied to improve or impact the lives of humans. So if I talk about biotechnology has a lot of like allied domains which does not just include to which does not just talk about uh, improving human life, but it also talks about clinical and biochemical ways of improving human life. Whereas biomedical engineering specifically focuses on using technological tools. Say, for example, your image processing. Image processing is a domain which has been there in the electronics communication sector for a very long time. But how do you use image processing to essentially solve medical problems? Say, for example, as Anish would talk to you about on how do you diagnose cancer or how do you identify a patient who might potentially have cancer using imaging techniques. So those are things which essentially fall under the broad domain of biomedical engineering. So in our domain especially, we studied a lot of interdisciplinary domains, interdisciplinary topics starting from anatomy, physiology, which involves giving us an exposure about giving us an exposure of the human body and also making us understand a bit of biology, which is essential for us to be able to apply engineering techniques to solve biological problems. So, in a nutshell, any engineering technique uh, which is applied to improve medical outcomes is what essentially falls under the domain of biomedical engineering.
Right. So maybe I would like you to bring you at this point, Anish, uh, since you have studied biotechnology. And we were discussing biotechnology and biomedical engineering differences, and now you're working on biomedical engineering. How do you find these two fields different?
So actually, I was just going to say that I'm not very sure whether they are different or they should be different from the personal point of view, because I mean, like, I sort of got into this field which I actually call as health tech through a series of steps which was just about like learning different things, and then in the end I found that the world needs a particular kind of like solution, and then I happened to have the skills which I could fill in with that. And so if you're going to ask me how do I separate them, I'm not sure I do, because beyond the point, as a person in the world or in the society, I think the best thing that you can do is find where your skills fit, and they don't always fit in the exact field which you trained in. Because I mean, like, for example, when I did my biotech, I have done everything from quantum mechanics to plant tissue culture to with the statistical mechanics and a bunch of things. And then in fact, I wasn't very strong in the whole lab programming and that kind of aspect. But I realized that if I can pick up some of those tools, I can solve some very difficult problems. And so in the end, that was the intention, which is like, I want to solve a particular problem. What are the tools which I need? And I was able to see that because of the position I was in. And so, I mean, like, I'm not sure how to like differentiate those if you really ask me. But I would say that I mean, like in any kind of course, I guess, when you learn a set of skills, that gives you a perspective on the world, and based on that, you see a certain set of like, problems that you can solve. So I mean, like, I don't think that answers your question, but like, that is like my view on the whole.
I understand. No, I mean, normally whenever we talk to students, or even in case of parents who are interested in taking admissions, mostly people end up asking this question: what is the difference between biotech and biomedical engineering, or let's say bioengineering? All these kind of words which exist about the same field on the different applications for sure. But there are very minor differences in terms of course. Normally, there is no basic difference. In terms of application, there are some differences, of course, because one application could be on the technology side, or let's say the medicine side. One application could be on the pharmaceutical side, and those kind of differences. Those are very minor differences, not very large differences, of course. And then that's
I think especially in our undergrad at NIT Rockler, we had both the disciplines under the same department, and now people who have studied bioengineering have gone on to do computational programming, whereas people who have studied bioengineering have gone on to do different things. So I think essentially it comes to the point, as Anish said, of what problem do you want to solve and how do you gather the right skill sets to be able to solve the problem.
Definitely. So that's I'm glad both of you have spoken about the skill sets that you have gathered on your way. So I would again go back to Anish on that question actually. So since you moved from biotechnology, which is more of a hands-on, non I should not say non-digitized, but let's say you are not using as much computers in that case, or as much computing in that case. You are working more in lab in that case, right? So you moved from that kind of a work to launching a company which is working on AI-based diagnosis.
Right.
So what kind of skill sets did you pick on the way? Like maybe students might be interested in, especially the students who are looking, who are I don't know if the CSE students have joined today, but they might be interested in knowing that. So they might be interested in knowing that what kind of skill sets did you pick on the way, because they would certainly be interested in applications of artificial intelligence.
Okay, so I mean, okay, I mean, like AI comes afterwards. Okay, so let's start where I started off, which was my original first love in like biotech was actually on the plant tissue culture side. And what happened there was that I did one experiment.
I must stop you there. That even I'm surprised to know that.
Exactly, right? Exactly. So like what happened there was that I was able to start some experiments in one, I mean, like using like agrobacterium and that kind of stuff. But in the end, I was able to do one experiment in 6 months. And
I can understand.
Because of my nature, I was very impatient. I'm like, okay, like no more of this. I'm going to go back to cell biology. And so that's where I started off that stuff. And in the first year of my PhD, I realized that I don't like to do analysis by hand. And so that's where I said, okay, I'm not good at like programming at all, but I know that like things like this can be solved by programming. And so the first program which I actually wrote was in MATLAB, and it was like a very like a simple thing where it would just load the image, it would tell me to outline the thing, and then I would outline it, and then it would store the outline and then like measure the intensity and the area or whatever. And so that was the first step, going from the science part, which is like what do I want to answer, to building the like technology part, which is which is saying that how can I improve my life by solving the problem which I have. And so this was back in 2009, before AI became a big thing again. I mean, like AI has had around like three or four waves in the past. I mean, like, dating back to the 60s and like 70s. And so when I was there, this was like a low time. And so then basically from there on, I sort of just kept improving that like system. Eventually, I learned that you can extract features about cells. And once you can extract features, you can do like statistical like, modeling. You can learn to automatically differentiate between cell types, right? And then so basically, if you want to look at it, I was like driven by laziness, which is to say, like I mean, like I want to do the most amount of work with the shortest amount of effort. And so what I was able to do was I was able to take analysis which would have taken me like 3 or 4 weeks and cut it down to about to about like 10 minutes. Right. And then I thought, okay, how can I be lazier, right? And so that's where I started like, I mean, just like googling stuff about automatic like feature design and that kind of stuff. That's where I learned that there's this thing called as like deep learning, and then all of that which existed. This was towards the last year of my PhD, and so instead of like writing my thesis, I spent like a lot of time learning about this, and then I wrote my thesis in a hurry. But that's like a different story. But then I mean, like that's where I learned that okay, like this stuff can be done automatically, and so that was the next step, which is I taught myself how to do deep learning and that kind of stuff, and then at the end I was left with a set of skills where I understood biology right from the point of view from say bacteria, because I worked with those. I had worked with bacteriophages. I had worked with like cell cultures. I had worked with plants. I had done microscopy. Then I knew like programming, and so all of this like gave me like a unique view on the world. And at that point of time, I mean, like I had always like wanted to start a company, and so I said, okay, I have these skills. What is the problem in the world which I can solve with these? And with that, I mean, like me and my co-founder, we went around and just to I mean, like random like doctors and said, can we help you? And it turned out that most of them did not need any help because medicine is like innovating all the time, except in the field of pathology. Because at that point of time, a lot of like digital like transformation had not occurred. And so there we were sort of right place at the right time, asking the right question, because of which we had the right skills. And then we could like combine all of this to say, okay, now we are going to build this. And so that whole thing is the journey. If you were to ask me from the biotech to biomed. And so it wasn't a conscious one. It was one which was like driven by like curiosity and the desire to solve difficult problem. And so that's where it comes from.
Yeah. I mean, I definitely agree with you that most of the time we don't plan it. It happens just out of interest. So yeah, I mean, even I think Ronak even moved from biomedical engineering to telemedicine. Very different kind of field. Again, a very promising field currently, telemedicine, from different aspects, of course. And certainly, coronavirus pandemic has given a major push to it in many different ways. So that's, I mean, that's something that I have been discussing with a lot of people generally, that how they have learned different kind of tricks and the skills that they have picked up on the way. So even from Ronak, I would first want to know. I mean, I would first want you to tell people what telemedicine is exactly, because it's a fairly new word generally for the world, especially for the new generation. And then maybe you can enlighten again similarly as Anish, what kind of skills did you pick on the way? Because I know some of it was planned by you, not exactly to end up in telemedicine, but but to get into more of a managerial position.
Sure. So I think, so essentially, if I were to start off on what telemedicine is, so I think telemedicine is a very specific domain which talks about uh, giving medicine through technology. I would probably take it a step back and say the right word is probably teleconsultation, which is how the government is even trying to define it. Because what is essentially happening is, so India is a country where access to healthcare is next to zero. So for people in the rural areas, or even in two-tier cities, don't have access to good healthcare. All our healthcare is primarily focused in the big cities in the country and in and around the metros, because that is where the people can actually pay for healthcare, whereas people in the rural segment cannot pay for healthcare. So this problem had been existing since a while, and the government was essentially trying to think and break its head on how can healthcare be made more accessible. So the government also tried pushing doctors, making it mandatory to go and serve in rural areas, but somehow that was also not working. So people who had the best of education in our country in good government medical colleges, they also weren't willing to actually go to rural areas and spend time there because of lack of a good quality of life. So so initially telemedicine was started off by a few like NGOs and uh, like public health organizations which were based in the rural segment and which wanted to kind of bring access to healthcare. But there were a lot of impediments because uh, data was not there. When you're trying to connect to a doctor through a video call or through an audio call, internet is a big problem in rural areas. So now
Yes.
with Geo coming in the last 3 to 4 years, we have seen a big shift on how data is being consumed by the country. So I would say part of this revolution is because Geo kind of came into the picture and helped get data accessibility and internet help solving internet problem issues. So so I would say COVID came in at a time where none of us had foreseen it would come. There were obviously a lot of negative sides to it, but one good thing which kind of came out of it is now everybody needs access to healthcare. But now because of COVID, because of lockdown, people were not able to get access to healthcare. So what essentially the government of India tried to do is solve this problem of getting access to healthcare for people who are sitting in their homes. So teleconsultation is nothing but making healthcare accessible for people who cannot visit a doctor. So say for example, there are close to 9 lakh doctors in the country who are sitting in their homes. Patients cannot visit these doctors. So what teleconsultation essentially does is making a channel of communication between the doctor and the patient. So now this channel of communication can be via chat, can be via messaging, can be via phone call, can be via video call also. It depends on the complexity of uh, what kind of communication needs to happen between the doctor and the patient. Say for example, if the patient is showing symptoms of cough or symptoms of redness in the eye, where the doctor actually needs to see the patient to be able to figure out whether the patient needs what kind of care. So teleconsultation essentially bridges this gap between the patient and the doctor, and it is done via, it could be, as I said, it could be done via chat, it could be done uh, via phone call, via video call, and all of it. So uh, I think what essentially happened because of COVID is now the MCI, which is Medical Council of India, got together with Niti Aayog and they framed these guidelines on uh, guidelines and broadly defining loose guidelines on what telemedicine can contain and what teleconsultation cannot contain. Because earlier, what used to happen is a lot of doctors were trying to practice on their own, but the medical community in general is very close knit, and they go to strike for any other thing. So getting adoption across them is very difficult. Essentially, a lot of private players were trying to do it. Apollo has been trying to do it in India since early 2016, but not a lot of doctors were actually using it because they didn't find a need. And like adoption to technology is kind of a bit tricky when it comes to doctors. So now with Niti Aayog kind of making that push, a lot of doctors are trying to get onto these platforms. So that is how I feel in the times to come, teleconsultation will pick up in a big way, because now for routine consultation, say for example, I'm having cough, I need not travel 5 kilometers to visit a doctor to tell that doctor I have cough. I can just call up the doctor, or I can just get on a video call with the doctor and uh, tell them that I'm having symptoms of cough, and the doctor can essentially tell me whatever medication I need to take. So this solves a lot of capacity and bandwidth issues in the hospitals, and patients will now not go to doctor for any random reason. They will only go to a doctor if the case is critical. So this is another way of solving the problem of lack of doctors which we have in the country, because right
Right.
now the doctor can essentially just, when he's done with his hospital duties, he can just come back home and switch on his teleconsultation module or give his number to a provider. So the provider
Right.
then finds a way to connect the patient and the doctor, and consultation happens between them. So
Right.
that is the first part on what teleconsultation essentially is just a bridge between the doctor and the patient. So
Right.
what was the second part of the question? Sorry.
I'm so sorry.
Okay.
Yes, I asked you two questions which are slightly disconnected with each other. Yeah,
Okay.
so I wanted you to maybe highlight on the skills that you have picked on the way to actually end up in teleconsultation.
Sure. So I think so. I have always like I did my bachelor's in biomedical engineering, where we were exposed to a lot of digital tools, be it courses in programming, where we just learned to basically code C and C++, understand data models, understand data structures, and also we also had exposure to a lot of biology tools and healthcare uh, like techniques and tools and different kind of devices and equipments. So when I went on for my PhD, I was essentially trying to work in the field of pain relief, which is we are trying to see how we can build devices. But
Right.
what I realized in during the journey of my PhD is devices is one domain, especially in medical device domain. It takes a lot of gestation time for takes a lot of time for starting from when you conceptualize the idea to building a proof of concept, getting all the regulatories in place, and then ensuring that there are doctors adopting it. And once you have a initial set of doctors adopting it, then it kind of flows on through hospitals and their set of doctors who are a part of, say, a particular group or a particular medical council. So there's a
Right.
lot of gestation period which happens in the domain of medical devices. So that is
Yes.
how, like, I kept participating in various hackathons which used to happen in Singapore at that point of time. So I kind of got intrigued towards solving large scale problems using technology as a medium, and that is how I participated in one of the hackathons, which the Singapore government was trying to do with MIT on solving problems for the elderly in Singapore. So the Singapore government in general has a lot of initiatives for the elderly, and has a lot of IT penetration, because the number of smartphone users, the adoption to technology barrier is comparatively lesser as compared to India. India is also kind of picking up now, and right now we have a lot of more smartphone users than we had, like, say, 5 years back. So that kind of uh, made me uh, intrigued towards I how can I use my critical thinking and logical thinking ability to solve higher order problems in healthcare. So I started working with a nonprofit based out of Bombay initially, where they were essentially trying to solve the problem for a couple of villages in Odisha, for a couple of prisons in Haiti, and a remote village in Philippines where people did not have any access to healthcare. So they did have a solution in place where what they're essentially trying to do is use a normal mobile phone just to capture the data, not from the patient, but with health workers interfacing with the patients, where it was nothing but a basic set of questions like, how if you have fever, how many days do you have it from, what are the other symptoms that you are also having. So there's it's just a simple mobile tool which can be used to capture this data, and then this data is sent via server to a doctor which is sitting in, say, a metro like Bangalore, or a metro like Bangalore or Delhi. The best of doctors can have access to this data. All that they need to do is just go through that history and then give a couple of medications. So I think I kind of realized the challenge which patients today face, especially where they don't have any access to healthcare, and how can it be made simpler using just essentially collecting data from the patients and transmitting it via server into the doctor, which
Right.
which who would probably not need more than a couple of minutes to just go through the data and provide a set of medications. So that is how I kind of got involved into this entire telemedicine domain, primarily because of my exposure in the health sector, and because of my education and exposure in health sector, and seeing how technology can play a tool in getting data and receiving data, and also making clinical decision making faster. So that is how I kind of move towards this domain. And I think in terms of skill sets, it's just my exposure to different kind of like different healthcare technologies, and different healthcare terminologies which are essential, and also a lot of reading on what how standardized medical dictionaries are defined. So there are international standards like SNOMED, uh, which defines clinical data dictionaries, and then there is FHIR, which is again uh, so what essentially happens is different systems. There are different systems across the country, and one of the biggest problems with healthcare is no two systems actually speak to each other. Say one hospital will have its own set of data management systems, whereas another hospital will have its own set of data management systems. A laboratory will have its own data management system, and no two systems speak to each other, which is a big trouble when you're trying to integrate systems across different hospitals or across different laboratories. So
Right.
what you have, say for example, you consult a doctor in a hospital, and then you take a handwritten printed report and take it to the laboratory to get your test done, and then you take a printout from there again and come back again to the doctor to show that report. Whereas all of this could essentially be solved if there was one standard dictionary which could define how these different data systems speak to each other. So I
Of
did a
course.
lot of reading on how the world kind of defines it in terms of different data dictionaries, and then looking at how can we make these systems interoperable and make them speak to each other, so that it essentially solves the problem of having all the health records at one place and then sharing it as you want. So one of the biggest like I would say inspiration in this during this time was Aadhaar framework, which came about, which essentially created one unique identity for an individual and made data sharing from one bank to the other, or from one system to the other, easier. So if there is something which could be done in healthcare, which could streamline this entire ecosystem, so that is what kind of drove me towards studying data models and studying systems on how they can be made interoperable. And there is no bigger use case than healthcare, where it is kind of needed the most. So those are the kind of problems that we are trying to solve through telemedicine and teleconsultation. Sorry, teleconsultation is one such tool which can
Right.
essentially make this job simpler of making different data systems speak to each other.
Sure. Yeah. So from at this point, maybe Ronak, it was very useful to know more about telemedicine and how you have made this transition from biomedical engineering to teleconsultation. Sorry. Yeah. Uh, but then, so from Anish, since we were talking so much about how a big field works, I would like to narrow it down to maybe how the startups work actually. And then the first thing I would want to know from you is basically, because not a lot of biologists end up being CEO in a I mean, they do not start a company. Normally,
Okay.
technologists do that more often. And if you are when we are doing PhD, especially in the field of biology, people tend to work more in labs and industry at most. They do not go for. I mean, of course, the startup culture has become more predominant these days. But I think when you would have decided to start a company for yourself, uh, I I think that was already in PhD when you had made this decision, right? Uh, there was something else that you were working on before you started this, but but yeah. So I just wanted to know that if you had any barriers to do that, because when we talk about biologists, uh, uh, they, I mean, there is always how should I put it? Maybe an internal barrier, like a mental barrier that we create for ourselves generally, and then people don't end up going into the big riskier field of startups. So maybe it would be nice to hear from you that if you had any barriers for yourself or from the world, and then how did you actually break them to enter the startup field?
Okay, so I would like to address a couple of points which you mentioned.
Right.
So okay, first of all, I would like to say just the fact that you're organizing this is something amazing,
Thank
because this helps expose people to ideas.
you.
Okay,
Of course.
and so this comes on to my second point, which is like where you said that not a lot of like biologists start companies. I would actually say that not a lot of biologists see other biologists starting companies, mostly because of the fact that like biology is slow, right? I mean, like just a fact from, I mean, like compared to say IT like companies where you can write an app, I think nowadays in I think like one day. I mean, like
Yeah.
you can have like a functional app. But whereas in biology, you have to do the experiments, you have to make sure it works, and then it comes to my market. And so what happens is that by the time the person starts it to the time they get the result, time has passed, and because of that, that person's peers end up losing track, and
Of
so
course.
they don't see that per person like doing the thing. Whereas in reality, now that I'm in the field and I'm seeing more and more people, there are a lot of people who are actually doing this. In fact, many professors end up having at least small side businesses where they are either doing consulting or they are, I mean, like trying to convert their basically research into to applied stuff. The only difference is that people don't talk about it, and I think that is because of the time lag which is there between
Yeah.
like, when you start and then like and then when you see results, which is like different for say engineering, mostly because they're working in a field where the basics are like proven. I mean, like a gear works like a gear, electricity. I mean, like you know how it works. All that you have to do is to put it two together in a configuration which works. Whereas
Yeah.
bio is not quite in that kind of a situation where you can just like plug genes together. I mean, like maybe people are trying to do that, but it's not there yet, right? And so I think that's the point where I mean, like because of which like you don't see like people like transitioning. So I mean, first of all, people do it. They do it a good bit. In fact, if you really like, will like think about it on the broad scale, think about any doctor who has a private clinic. Technically,
Of
they
course.
are a biologist and they have their own business, right?
Right.
And so, I mean, like people do it. Now the second part. I mean, like this is where it's related to the question which you asked about risk, where
Right.
where it's a risky thing to do. So the thing is that if you think that something is risky, you should not be doing it, right?
Hmm.
And so that is also true for any kind of like company or venture or then anything which you go into. And so I mean, like if you were to ask me when I wanted to start a company, it was probably very early on, and that's not because I had an idea or something like that. I just I was sort of always attracted to this idea of really setting things up and then like making them work.
Right.
And so like I would organize like college fests. I would organize really some like cultural events, and so that part of me was always interested in like doing something new. And so like a company is sort of uh, like a direct flow from that like mindset. Okay, and so now when you do a college fest, you don't do one with the mindset that, oh, this is not going to be very good. No. I mean, like we just do like a very dance performance, and it'll be like the worst dance that we'll ever do. that
Yeah.
that is then, I mean, like, never the case. I mean, like, what you do is that you find your best dancers, you find your best singers, and you put on the best show that you can, because you go with the assumption that that is going to be I mean, like, really great. Now, when it's time to start a company, the first thing which you should do is to verify whether or not the problem which you want to solve is worth solving. Before you do anything, forgetly writing code, forgetly designing anything, the first step which you have to do is you have to go and talk to the customers who you want to serve. And if you don't know whether there are customers, you have to first figure out if there are going to be customers. Now, I mean, like this is because that's the point of a business, which is to serve a customer and to do that by innovating, right? I mean, like those are the only two functions of any startup or in fact any like a company. And if you can't do these two things, you cannot. I mean, like that cycle can't be fed. Okay, and so there I would actually say that if you're starting a company with the mindset that this is a risky thing or I'm going to take a risk, don't do it because you have not done your research, and that's why you feel unsure about everything. So the first thing would be to make sure, I mean, like, which is the mistake which I actually made with my first startup, which I attempted to start in the middle of my PhD because I thought, oh, microfluidics is something really cool. I can do it. And let's start like a company about that. Whereas what I should have done was I should have gone and asked, does anyone need this tech?
Right.
And it turned out that the only people who wanted it were in research, and the research people tend to do this stuff on their own, and so there was no market for it, which is what I learned by doing this. But in reality, this is a simple rule, which is like don't do anything which you haven't like verified first. And so that's where the risk aspect comes in, where you should verify that there is little to no risk from the unique point of view that you have. Because the thing is that if you say talk to a person, I don't know, pick a field. I mean, like okay, like Manish like Vibhute looks like a bodybuilding kind of a person. So let's just like go with that. Okay, let's see. Let's say that you go and talk to a gym manager. Okay,
Right.
and you ask them, okay, do you think it's worthwhile that I should start a company which is about like drugs which are against like malaria? Now that guy is going to be like, I don't know, but it sounds very like risky, right? But
Right.
now, so suppose you have the right background where you say, actually, like I have this like this the unique like knowledge where this particular gene I can tweak and I can attack, based on which my risk goes down. So the world's perceived risk is higher because they don't have your point of view.
Sure.
But because you have that point of view where you can bring down the risk for yourself, that is like what you want. And this, I mean, like there's a formal term for this, which is called as a barrier to entry, which means that you see the opportunity, but others don't because they don't have your unique like knowledge. And so I would say that don't do like something which you feel is risky, and only go for those things which you know are of low risk. And this again like comes back to your question, which was about like how did I do this, and like, why don't more people do this? If you really look into the field, you have investment companies which are called as venture capital companies, which are whose entire like system works only by investing in healthcare companies, right?
Okay.
And so which means that the ecosystem is strong enough. I mean, just as a very high level indicator, right? It means that the ecosystem is strong enough that there are enough such companies coming into play, and enough people can communicate that there is not as much risk in what they are doing because of their team or their skills or their technology, and that I mean, it reduces the risk of those investors, and therefore they are willing to invest. And so that's the entire thing. And so that's, I mean, like I don't quite know how to like summarize that, because it's a bunch of like different things which you learn individually, they were one by one, and then you like put together. And so yeah, I mean, like if you're planning to start a company, do it with the intention of solving a problem which not that many people are solving, and which you sort of have the unique set of skills to do. Don't start one if you think that this is high risk, because if you think it's high risk and you go and incorporate a company, you are stuck with all this like paperwork, which is like company secretary and all of that stuff, which is not what the company is really about. It is about being able to like deliver your solution. and you can't do that unless you're verified that the problem is solvable and you can solve it. So that's my takeaway, I guess.
Yeah, so going now, I would like to bring back to your company. Is that
Yeah.
how are you guys actually using AI for disease diagnosis? Actually, I mean, because people talk about it a lot, and
Yeah.
I'm sure people would be. I mean, of course, students would be interested to know how AI is used for actually used for this this purpose.
Okay. Let me see. Um, so okay, if you really look at it, right? I mean, like if I were to put it in the simplest possible terms, AI is just a computer program.
Right,
And if you know your basic like matrix calculations, it is just like millions of matrix calculations being done at the same time. I mean, like, at least what people commonly they refer to as AI, which is deep learning. That is basically what it is, and the system is able to learn various kinds of features on its own. This can be from images, it can be from sound, text, anything which you can put into any kind of an order, or there is a pattern in it. The system can learn to read, and it can
right,
have a certain level of accuracy in it. Now this goes back to I guess it's technically called information theory, but the thing which you're analyzing has to contain the information with which you can get the answer, and so it can be very complicated. But AI can't do magic. It can't say like look at the picture of of a wall and say, oh, this wall must be in the US or in South Africa or in Singapore or something like that, right? It can't do that kind of stuff. And so when it comes to like diagnosing disease, how it basically works is that you have your training data and you have doctors who have told us how, I mean, like, what the diagnosis is for that data type. I mean, like, this can
like
be
by
like
eye.
various things.
Yeah,
Sorry?
by eye. I mean, normally
by
how
by by,
they
by, by eye
diagnose.
or by experience. I mean, like sometimes what they'll do is that they'll know that this is the hemoglobin level, this is the sugar level, and then they can like combine all those things based on
Right,
the things which they have learned and say that okay, this means X
right,
disease. And then you take all of those parameters, which can be like 10 numbers, or it can be like millions of pixels, and you can give it the answer, saying that this is the answer. And there
right.
are I mean, like, I won't go into all of the like, technical details, but there are many different ways that you can play with the statistics and the machine learning part of it to make the computer learn that pattern,
Right.
and then you give the doctor the answer. Okay, now the second part, which is to actually correct your question a little bit, which is you asked me, I mean, how do we do diagnosis? Very technically, we don't do diagnosis. We can, but we don't. Mostly because we want to make sure that the doctors who we are using, we are like, serving, they have to be convinced that the system is giving good answers,
Okay.
and and so they are actually being assisted by our system, and it's
Right.
by using our system that they are able to do more work. And so
Right.
very realistically, the problem that we are actually solving is that we are enabling pathology labs to do more number of cases every day and to serve more patients, because
Right.
currently the world is facing an extreme shortage of pathologists. Basically, we need about 5 times as many pathologists in the world as we have, right?
Yeah.
And so that's the problem which you're solving. It just so happens that we are solving it with the help of AI.
Of
Well,
course.
Raunak has another approach where that can also be solved through some kind of like telemedicine like techniques. But basically, it's about being able to serve a larger number of patients. Okay, and so there, what we do is what is technically called as assisted. It is called as like diagnostic assistance.
Right.
And so that is, we just like give the doctors the answers faster. And so for example, there is a test called as Ki-67, which is like immunohistochemistry test, where you're supposed to stain like tissues and you're supposed to count the ratio of brown cells is to blue cells.
Okay.
Most doctors end up doing this by eye and be like, okay, this looks like about like 50% or 60%. But if
Right.
there's a difference of 10% in in what they are measuring, then the treatment which the patient gets is very different, and that
Of
is
course.
bad for patients. And so now here the system, I mean, like our system can do cell level analysis in about 5 minutes of an image which is between 3 to 10 gigabytes, right? I mean,
Wow.
like a single image is that big. And if a doctor were to actually do this at the same level as us, he'll probably take over a week for that one image, right?
Wow.
And so yeah, and so now we're able to give the doctors much more accurate results of such tests. And now it's their job to say that, okay, I have this very accurate number. How can I use this to treat the patient? That's
Of
what we
course.
are doing.
Yeah. So
Yeah.
you're sort of
Yeah.
serving the doctor in shortening the time, sort of.
Exactly. Yes.
Yeah, yeah.
Yeah.
So since we have talked so much about both of your fields, I just wanted to get an idea from both of you. Actually, is that
Mhm.
I will begin with Ronak in this case. That since he comes from I mean, he has been studying in the field for a very long time now. Is that so? You would have studied some parts of it of biomedical engineering when you began as an undergrad, and now you're working in one of the arms of it. So how have you seen the field developing in past 10 years? I'm not sure if it's already been 10 years since you did started your undergrad, but yeah, that's my guess. So yeah, in past 10 years, and then since there's a lot of changes in the field for sure, thanks to development in technologies. Where do you see? I mean, of course, when you're in the field, you have some idea that where do you see this field going forward? Like, because most of the people who would be starting their education now, they would be graduating in 4 years, and a lot of things change in 4 years, especially in technology. So yeah, I mean, just to give them an idea where they would be seeing themselves, or which arenas they should be looking forward to. Yeah, so
Sure.
so let's
I think
begin with you.
I whenever I think of whenever I think of my career in retrospective, I remember a conversation with my director when I went for my counseling. We were the second batch in biomedical engineering in our college, and our director told us at that point of time that you are studying a discipline where you'll have 10 jobs after you graduate. None of this that at that point of time kind of became true, but I think what essentially is happening right now is there's a lot of two industries which I feel kind of never stagnate. One is the food and beverage industry, and second is health. Because the more and more the kind of lifestyle that we keep having now, and so health problems is something which people will have at any point of time. So right now, with the advent of technology coming in, the longevity of life is increasing. People have more money to be able to pay for good healthcare. So
Right,
the way the industry is developing, and the use of technology in the industry is kind of growing day by day. If I remember from when I started 12 years back, at that point of time, as Anish said, there was because of the way things in biology are perceived, nobody is actually thinking of doing startups, especially in the healthcare domain. But
yeah,
right now, with access to technology, with access to machine learning tools, with access to faster prototyping skills, with access to better digital frameworks, so I think the field is kind of growing in different directions. It's on the individual on how they want to utilize whatever they have gained, or whatever skill sets they have gained in whatever domain that they want to. So I think there are a lot of initiatives happening right now within the country, especially by DBT, Department of Biotechnology, BIRAC, and then a lot of uh, like uh, a lot of uh, Tata Trust, and a lot of such incubators which are being developed across the country, where all they're trying to do is take a lot of these research labs and technology which are being developed, and taking it through to the stage of commercialization. So there's a lot of traction happening all around, and India, by the virtue of it, has a lot of potential for there are a lot of medical problems which we have in the country right now, starting from access to better diagnosis, to making the lives of, say, for example, the doctor to patient ratio in India is not good, which is where
yeah,
technology like the one Anish is developing will help decision making faster for the doctors, to
Yes.
enabling access to basically developing vaccines or developing like I would say technologies which can also treat. So there is the part of prevention, there is the part of decision making made being made easier for the doctors. There is a part of treatment. There is a part of care. There is a part of information access. So these are multiple disciplines which are emerging within the healthcare ecosystem, and all that one needs to do at this point is just being aware of what are the different opportunities out there. Uh, Network with people, read about technologies which are there, which give you an idea of what is happening across the sector, and then basis the skill set that you have gained or basis the problem that you want to solve, uh, take up take up or build skill sets in that particular domain, uh, and work on that path. So I think there is a lot of traction happening within the ecosystem right now, and I would say like I have a personal feeling that there is no better domain to be involved in at this point of time other than healthcare, just because of the kind of like developments traction happening, not just from a research perspective, but also investors getting into it, playing, wanting to play the long game, researchers coming out of the closet and wanting to solve difficult problems.
Yeah.
Big companies like Reliance, Tata, everyone is kind of getting Google, everyone is getting into healthcare because they realize the magnitude of the problem and how it can make life simpler. So there is traction from all sides, and I think it's just dependent on the individual of taking that step and wanting to looking at what problem they want to solve, and then kind of getting the skill set that is needed to be able to solve that problem and build a career in that domain.
Right. So, Anish, I have the same question for you. That what kind of startups do you see in this field normally, which do well, first of all, and even those which the ideas that you found very impressive. I'm sure you would have heard of a lot of ideas which are extremely impressive. So yeah, I mean, I'm not asking you to do I mean, most of the companies, as they are launched, it is not stealing of idea, I'm sure, but
No,
yes,
no.
people will get to
So
know
actually,
about what.
I just want to understand the context of your question. Is the context of your question to give the students and the audience like an idea of what kind of stuff they can do, or what is being done now, or what's the idea?
Both. If you
Both.
if
Okay.
you if you can give an idea on both, that's perfect. If you could
Okay.
talk about at least things which are being done now, that's also
Yeah.
very useful. Yeah, yeah.
Okay. So in that case, I will actually start with the thing which I think is actually useful for a young person, especially in the first couple of years out of school, right? So for some reason, people always want to be in the field which is hot right now. So, for example, if you were to ask me when I started my undergrad in 2003, should you be doing biotechnology? There was nothing happening that time. I mean, IT was the hot thing. I should have gone and learned like C script and like Python and then all of that, and because that was a hot field of the day. But the fact is that so all technologies. I mean, like this is like a natural way that the world progresses. Okay, where you basically start from technology now, new, that gets commoditized, which means that it gets packaged into a product, and ultimately it becomes a utility, right? Which means that like what I mean, like back in the day, electricity was a very new thing. I mean, like people had like candles and like, oh, we have a light bulb, such a cool thing, and now we take it for granted.
Yeah,
Similarly, now anyone can start a web page. When I made my first web page, it took me. I mean, like back in like '96, I think it took me like a week just to be able to figure out how can I put this like fireball bullet point, right? Because it wasn't there. Now I can do it in literally 30 seconds. I mean, we use emoji all the time, right?
yeah,
And so don't try to be in the field which is hot right now, because that's going to become a field which will just be like a matter of fact in the future. I mean, like in fact, most programmers I expect to become automated within a few years, right? And so I think it's a futile attempt even to guess what the future is going to look like because things change. I mean, like for example, earlier like Ronak like mentioned that no one foresaw COVID coming. Actually, that's not true. I mean, like people have been like talking about having like a pandemic for a long time. I mean, like it's just like a statistical fact that that is like going to happen. It is that like no one paid attention to it. Right now, if someone had paid attention and they had like developed all this tech, now was the time when they could have really like leveraged that. So the idea is try to be where the ball is going to be, not what is hot right now, right? And so that I think is better to understand than saying okay, what is hot right now? Because what is hot right now is already being worked on, right? It's I mean like I don't know if you guys teach people about like cell culture, but then I mean like DMEM
Unfortunately, we
is
do.
okay, great. Okay, and so in that case, you know that like DMEM is a thing which you use for cell culture, right? Now, if you were there when this media was being like developed, people were thinking, oh, this is the new big thing, and some I think like 50 different kinds of media existed. But by the time it was standardized, people didn't care about the others, and so there, if like people had gotten into the field saying, "Oh, I'm going to like develop cell culture media." By the time you passed out, it was done, and so then, uh, and the and the other point which like Ronak also said, which is like healthcare is always going to be hot and that kind of stuff. If we actually reflect, both of us are currently working on technologies which will make it easier and easier for healthcare to be delivered to people. So the question is healthcare really going to be hot in 10 years? I mean, I'm not saying that that is not going to be, but the question is, are you sure? And I know I'm not. I mean, I don't know because I am personally actively working to make sure that it's easier to get care, right? And so there, uh, and this applies to all the cool tech which I have seen, which includes AI for like X-rays. I mean, like I mean, like unique like fluid dynamics based. What's it called? Like a sonogram. I mean, like analysis which can like predict stroke ages ahead of time. That kind of stuff. And so like, all this stuff is already being worked on. The only thing which is important is that when you are ready and when you have the skill sets, which is also what Leonak said at the end, when you have passed out and when you have a certain set of skills, go back and see as like an individual, right? Where me having the skills I have, I mean like some people are great at like being on stage, some people are great at the analysis, and some people are great at really talking to other people. Now combine all of your skills. I mean, like you are not just an engineer; you are an individual who has, I mean, like who is made up of all the experiences which they have in life, and not just your degree. And from that point of view, figure out what you can solve and where you can make the most impact. And that is the way to be where the ball is. Because if you try and make plans based on what is hot right now, no matter what, you're almost guaranteed to miss the train because the world changes really, really fast.
Right. I'm glad both of you have spoken about this thing that world changes very, very fast, and then you have to think way ahead in time, maybe if possible, at least as much
I'm
as you
actually
can
saying
do, of
that
course.
you can't think way in time, and you shouldn't even attempt to. The only truth is that what is researched right now is going to be a product on the shelf tomorrow. Therefore,
Yes, of
don't.
course.
Yeah. So I mean, like
Yeah,
just try and find something unique which you think is cool. That's it.
yeah. So basically, find your own niche wherever you are, sort of.
Basically.
Yeah.
Yeah.
And
Yeah. Maybe this is this. Ronak, sorry, you wanted to say something.
so I think like it's important to identify what you want to do, looking at what is available, and then be able to adapt your skill sets also in that particular domain, because I think as technologies change very fast, if I have to think back 3 years before, the way data is being consumed now, data did not exist at 3 years from now, 3 years earlier in the same way. Like
Definitely.
Ola got built because Google Maps came into picture. If Google
Yeah.
Maps was not there, there would have been no Ola, no Uber. So I think it's just important to leverage on what is existing and then build on top of it, rather than building something out of the box which will not find any takers.
Yeah.
And also like utilizing what is out there and building on top of it and working on top of it is what is essential in today's world, is what I feel.
Yeah. So yeah, at this point, maybe we can take the questions from the audience. We have two questions. I think we have answered most of their questions, so we are left with only two questions. So first question is basically, what is the difference between biomechanics and biomedical engineering? Any of you can take it, depending upon your interests. Yeah.
That is not really my domain of expertise.
I hope
So I think
Saurav can
later on I
answer that.
can.
Else
Yeah.
Yeah,
else I will have to dive in.
sure. I think essentially it talks about it all falls under the broad domain of biomedical science. Biomechanics specifically focuses, if I have to identify the difference, it specifically focuses on using uh, like basically understanding physics and using physics to be able to solve problems in the biology field. Say, for example, uh, how much should my arm flex? Or
Yeah.
if I'm doing physiotherapy, how much, like what sort of cap should I build which will help my uh, help my bone be, like help my ankle be at the right shape. So it's basically a combination of mechanics, which is physics at its core, and then understanding how different body parts work according to physical rules, and then using engineering tools to be able to solve them is what biomechanics focuses on. And I think biomedical engineering again is a very broad domain. So I would say biomechanics is one subset under biomedical engineering. If you're specifically focusing on medical devices, which is a specific domain again under biomedical engineering. So that talks about using engineering tools like image processing, machine learning, AI to be able to solve medical problems.
Sure. So I think the next question would be for Anish, because somebody is asking exactly from what you do, is that how AI can be useful for cancer? I hope
Oh,
not
sorry.
for
Okay.
creating,
Okay. Sorry.
not for creating cancer.
I am assuming that means
Yeah,
how to
yeah, for
battle
solving.
cancer
Yeah,
and not to
yeah.
help cancer. Okay.
I hope so too. Yes,
Yes.
yes. Not for creating them.
So actually, think about it this way: that if you were given a super calculator, uh,
Yeah,
what kind of calculations could you do, right? And so AI can be applied for many things as long as you know what the process is. And so this can include optimizing, say doses for 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 like the different kinds of drugs, discovering like different maybe like drug combinations, then of course like diagnosis, which is what I'm working towards. Then uh, one of the things which was I was like trying to do in my PhD, which is to sorry, well after my PhD anyway, like trying to discover particular patterns which humans can't see, but
hmm,
then maybe like machines can. There's a lots and lots of things. I mean, like, this is like a very broad question. I think it's better to sort of first understand what cancer is, and and then say how can I solve this problem, and is AI the right tool? Because sometimes you might not even need that. Uh,
yeah,
Sometimes what you might need is essentially gene therapy, which AI might or might not use. I mean, like think of AI as a spreadsheet or a calculator. It is completely about how you apply it, and it all depends on the problem. So if you have a problem to solve, then you can use this as a fancy calculator. That's that's how I simplify it. But it is all very oriented towards the problem.
sure.
Yeah.
And the next question is for Ronak, actually, very specifically. How end citizens can take us seriously as doctors do via teleconsultations, as we are not so civilized on the whole. I'm not sure if I understand the question. If you do, then yes, please go ahead.
It's just like the way I would put it is, uh, if I am a patient and I have to consult a doctor, a good doctor who's seating whose clinic is 50 kilometers away, then what value am I getting in doing the same consultation online as compared to, or via a phone call or via teleconsultation, as compared to spending my energy and going there? So it's just more about a mindset shift which has to be brought in patients and driving home that value to patients. So for a simple thing as such as, I think all of us at some point also do the same, which is if we have a family doctor, we just call them up and say, hey, I'm having this cough or I'm having a heart pain. What medicine should I take? So that is also already a form of teleconsultation. So here, what you're trying to do is essentially take a step further and say you can actually avoid that visit to the doctor in case you don't have anything which is critical, which does not require critical care. You can just book an appointment, see all the list of doctors who are there for a teleconsult, and just get on to a teleconsult, describe your problem, and you would get back your prescription uh, right on your phone. So I think
Yeah,
it's just driving that value to the customer is when end citizens will actually start adopting it much faster. And also, I think what is essential is having that avenue to be able to use that for consulting with a doctor. So right now, a lot of startups, even the government of India is trying to build uh, its own teleconsult module in collaboration with a lot of the high funded health tech startups, which is Tracto, 1MG, Live Health, and a lot of these startups. They're trying to build an open source telemedicine platform as well. So a lot of platforms already do exist. It's just about having that mindset shift that rather than traveling so much, I can actually pay the same amount and get my consultation done and receive the medicines. So it's
right.
also about so the value is not just in terms of uh, being able to talk with a doctor and getting a diagnosis and medicines, but also if we can take one step further and integrate the system by getting medicines delivered to our home. So it's about how business people innovate to solve that problem for the end consumer is when the end citizens will also start taking it seriously.
Sure. And
So,
there's one last. Yeah.
I will
Go ahead.
actually disagree on two counts. One with the question, and the second with the answer.
Okay.
First, with the question which Mr. Le Babu had, which is we are not all very like civilized, and then how should we like take this like seriously? Uh, I kind of take a little bit of offense to that. Why that is because I am not say from the finance side, right? And so if someone uh, said to me that, hey, I have this amazing like investment opportunity, why don't you like give me all of your say savings, and then I will invest in it. Now if I know nothing about the world, why should I trust this person, right? Is the same thing with medicine, which is I have not been exposed to that technology or that kind of science, so it doesn't make sense for me, no matter who I am, to to trust something which is in the world. And so like, I would say this has nothing to do with being like civilized or then educated. It is simply a matter uh, of taking your own health seriously, where if you feel that you will get the best care if you visit a doctor in person, then that is the real thing. I mean, like that's what any person would care about. It has nothing to do with how I mean, like how like civilized or like uncivilized a person is. The second
Right.
part is about the answer, which is what like Ronak said about like driving home the value, making people realize that like this is good for them. The thing is that I mean, like, people are very smart. I mean, like I mean, look at all the forts around like Pupuna. I mean, like people were great engineers even before they had a T-square, right? I mean, like they were able to build forts. I mean, like you can't say that they didn't. That, I mean, like even if you look at like things like the Golconda Fort, they even understood acoustics, right? Maybe they didn't have like a formal theory of it, but they understood. So I would actually say that people understand really well what is there and what exists. And if you try to drive home the value, then it's not going to be as effective. But if you give them value, which is you actually solve a pain point which they have, or you make something easier in their life, they are going to adopt it. I mean, why do people use WhatsApp or then YouTube on their phones, or why did when Reliance first came out, why did people start like watching TV on the small little phones? Because it solved a problem which they had, which was about entertainment. Where now they were, able to sit in the middle of anywhere and just watch like TV. So if you're going to give them value, then they're going to take the value. But if you're going to try to teach them that, oh, this is good for you, then that's going to be a much more uphill like battle. And this I feel is something which technologies especially miss, that they try to say, oh, this is such a great technology, whereas that is not the question at all. Understand what the problem is, solve that problem, and that will by itself like drive home any of the value which you say that you're trying to drive home, because they'll adopt it on their own. Because if you go back to the civilization aspect, technically no one knows about the internet. There's no reason why like geos should succeed, right? But it succeeds because enough people gain value from it, right? And so that's the only thing which is it's not about like being like civilized. I think everyone understands when they see a good system, and it's not about like driving home the value, because you can't force feed someone technology. They have to like take it themselves, and like that's the only real way to make the world.
Driving home the value is so it's at the end of the day it's about getting care. So if people are getting care at the comfort of their homes, the same amount of care which they would receive while they are face to face with a doctor. So I think if businesses can innovate around giving that same amount of care when the customer is sitting at his home and versus traveling to a doctor. So I think if businesses can innovate around that and solve for the problem of having the same customer experience which a customer has, I think that solves the problem. And this
Yeah,
requires this
I mean, like that I agree with. I mean, like basically now you're saying that the problem to be solved is about trust. And so if
correct.
the technology can increase trust, yes, that I would say is right. But if you try to say that we are trying to tell the patients that you'll get the same level of care, there is no reason for them to trust it, right? But if you're solving the problem of trust, then yeah, sure.
Yeah, so
We can
it's
completely
about
agree.
solving the problem of trust, and also there are tons of telemedicine solutions right now. It's about how do you do it better than the others, and how do
Yeah.
you kind of which makes the difference between what a Yahoo search was and what a Google search was. It's about how you are kind of differentiating and making the lives of a customer easier, and also how differently and uh, how appealing is your proposition to the customer at the end of the day. So I think everybody solves a problem. Yahoo also solved the problem of search, but Google just did it better. Uh, there were tons of laptop solutions already there. Mac just did it better. So I think the first part is enabling that ecosystem of being able to solve a problem, and second is how do you kind of make it differently and solve the problem better than others.
Yeah, like currently I was facing a problem if I should go live on Facebook or Instagram, because most of the next generation is on Instagram.
It should have
So
an Instagram
yeah,
or even like TikTok, I think.
yeah, yeah. Maybe next time we should
Wait,
do that on
wait, that's like, I
those
mean, like,
platforms.
that's not supposed to be like a Chinese app, I think. Anyway, we should not get into that. Sorry, go ahead.
Yeah, no, because many of the students did not even have Facebook accounts. We
I
just
don't blame them.
realized
Yeah,
that. So
yeah,
I should not have been surprised out of it, but then
yeah.
yes, we had a similar
No,
kind
no,
of
I mean,
problem.
like, I think that the ideal like medium might be to make like a live like YouTube stream,
Yeah,
And
so
like,
that's
that
what
the
we
most,
are planning to do next time. So we go live on YouTube and then we can
awesome.
channel on different streams.
Yeah.
Yeah, that's the idea. All right. So there's one last question from Varad, which would be again I think for Ronak because he has taken this course before. That is biomedical engineering is really related to engineering, or is it better to opt for core subjects like mechanical or civil? Like
I think I
why
would
did
just
you choose biomedical? Let me go there then.
I, I think it's about what one wants at the end of the day.
Sure, of
It's
course.
as simple as that. Like I would say, uh, anything that you're doing. So like right now, people with even basic sciences are getting into doing AI, machine learning, and all of that. So it's just about what what is it that you want at the end of the day. What is your kick and what problem you're trying to solve, and direction is what which direction is like which direction do you want your career to be driven towards. I think it's
Right,
all about that. And like right now in today's world, there are a lot of interdisciplinary domains emerging. And like I kind of have uh, I have a simple philosophy which is more about, rather like in today's world, to be successful, it's not important to just be a master at one. It's also about having that broad exposure across different domains, because that is how you uh, get the ability to be able to solve much more higher order complex challenges. Like say for example, if I had to talk about any startup founder, if he only knew how to do research in a lab, he wouldn't be able to do a startup successfully. He would still need to go to talk to customers. He would still need to go to know like get skills on how to sell your solution, get skills on how to raise funding, get skills on how to manage people within the startup, get skills on how to drive them towards what the vision of the company is. So it's all about what is needed at that point of time, and what is it that you want to do is what people should kind of follow.
I'm just going to add my 2 cents on that because I think me and like Ronak have like, very like different personalities. I for a very long time did not know what I wanted to do because I mean like there's so much to do, and I felt like I know so little from where I am. Even at the end of PhD, I was like I'm not sure what I want to do, right? And so I think that the only thing which helps out is to be one, not be afraid of failure. I mean, like you could go for like civil engineering or biomed. There is value to be created in any field which you enter. In fact, I think if you find like something which you find interesting, you will learn all those things along the way. And so like uh, 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 we lately mentioned that like you need to have all the skills about like selling and like fundraising. You don't. You have to learn them along the way because that becomes a problem in the direction of the overall thing that you find interesting, right? And so I mean I'm more of the opinion that don't be afraid of failure. Don't try to second guess what your interest is. Just like go with one thing, see where it takes you, and at the end then see what you find interesting there. And again, don't be afraid of failure because first of all, you're not going to fail. It is a mindset of what's it called? Yeah, loss aversion, which is that, oh, I have something and I'm going to lose it. I would start with saying, oh, I don't have much. Let me see what I can do with what I have, right? And so that is the difference in like my mindset. And this, I mean, like, this is like different for different people because some people are very goal oriented, whereas I am personally much more interest oriented. And so when people told me, oh, you have to know what you want to do and then go towards that, like, dude, I don't know what I want to do. And if you go back to me in like 2003 in Pune, like, the only thing which I wanted to do was like race bikes on the Pune streets, and that's what I did. But that's not where I've ended up because after a while I was like, yeah, racing bikes is cool, but this whole biotech thing, I can make curd in a lab, and that's really kind of cool. And so, like, it was from like a thing of jumps off of just being interest based. and that's how like different people function differently. And even I was asking this question, like, should I do this or that? What is better for me? But in the end, no one could give me a good answer, and so I just ended up doing what felt interesting, and that can take you to interesting places. The important part is to not be afraid of failure, because if you're afraid of failure, then you've already given into that fear, and that's not great. So again, there is the caveat that you have to consider your personal like situation in life, where you might have to like support your parents. All of those things, of course, come into play. But I still think that all of those things can be done if you are able to uh, put. I mean, like, not create a niche for yourself, but find that niche where you fit in well. And the world is huge. There's so many people who need to do so many different things. I think you can do it. You just have to be willing to search and be active. And so that's the other point of view for the other kind of like students which are there who don't have a goal. It's totally cool. You'll be fine. Don't worry about it.
I'm glad you end up with that, because I try to tell them that every time that there is nothing to worry about. Usually, you pick up something that on the way while you are learning things. So you just continue to learn until you are
But
like
if you look at the IT industry, many people are taught like C and C++ in like the coding school. No one does it anymore. I mean, like, there's a new programming language. I think every year or so. I mean, like, when I was finishing my PhD, like Julia like came up, and now the TensorFlow and like PyTorch have like taken over. Things are going to change. You have to learn how to come.
Definitely.
I
So
think
at this,
I think it's just important to stay updated and keep yourself aware of what is happening around. Like the old idea of being stuck in one job all your life and not having jobs, I think that doesn't exist anymore. There are a plethora of opportunities. People shift from one domain to the other at any point of time. So it's just important to stay updated and pursue what interests you and carve out a niche for yourself, as Anish said, uh, in whatever is happening around you.
all right. So at this wonderful information and all the knowledge that people have got from you, maybe we'll stop the broadcast at this point. We have been talking for very long already. So yes, all right. No, but that was the idea. Yeah, same for me. Yes. Thank you very much, both of you. It was very insightful, both from knowledge point of view and, of course, from the perspective point of view, to see very different perspectives to the same thing, and also very very similar perspective to very different things. So yes, thank you very much, both of you. So we'll go offline now. All right. And for the audience, I'll see you again on Saturday next week.
Bye bye.
Bye.